Hey, it's Dr. J. 2.6 today, other types of equations. When I say other types, in particular, what I mean are rational equations and radical equations. Rational equations are equations that have variables in the denominator. You might remember from one of the previous lectures, I think it was 2.2, I mentioned that a linear equation cannot have a variable in the denominator. And that's still true. A linear equation cannot. Because if you have a variable in the denominator, it's not called a linear equation, it's called a rational equation. It comes from the word ratio. So if you have a ratio of a variable, that means there's a possibility of having a variable in the bottom, or in the denominator, that creates a separate category of equation. And then the second type that we're going to study today are called radical equations. Those are equations that have variables inside the radical. In particular, a square root. So we sometimes call these square root equations or radical equations. There are other types of roots, cube roots, fourth roots, fifth roots. We're not going to learn those today. Today we're just going to focus on the principal square root equations. Okay? I will make an important note before I do any problems. We must always check our answers. We have not been doing that lately, right? If you look back at the videos, I haven't really been checking my answers. There's two reasons for that. One is if you follow all the steps properly and you don't make a mathematical mistake, then your answer will be correct, okay, prior to 2.6. So in all of the lessons that we've done from 2.1 to 2.5, as long as you did everything right, there really was no need to check. So checking was really a matter of preference. If you prefer to check, you can, but you're not required to check your answers. However, and the other reason, I said there were two reasons. The other reason was time. In the interest of time, I'm videoing these lectures. They already last an hour, sometimes an hour and a half. Could you imagine that if I was checking every single problem before I could move on to the next problem, an hour lecture would turn into a 2-hour lecture and so on. So for the time reasons, I'm not going to spend a lot of time checking my answers if it's not necessary. Okay. However, in this section, with these two types of equations, there is the possibility of what are called extraneous solutions, or extraneous roots, they're sometimes called. Solutions and roots are sometimes called, they're synonymous with each other. Extraneous means that you didn't do anything wrong, right? You followed all the steps, you did the math correctly, you didn't make any mistakes, but still the answer is wrong. How do you like that, right? When you solve rationals and radicals, it opens up the possibility that you could not be at fault, yet your answer is still wrong. And because of that, you have to always check. You never know if your answer is going to be correct unless you actually check your answer. And so this lesson is going to take a little bit longer because I'm going to have to check every solution that I get. Let's go ahead and see one and see how this works. Example 1, solve for x. You might notice that these equations look a lot like linear equations, but they have variables in the denominator. And so that's what makes them rational and not linear. Okay. So we're going to solve them in much the same way that we solved the linear equation. The process is going to play out a lot like the previous problems, but when we're done, we're not really done. Every time you finish, you have to go back and check your answer. So we're going to try to find the LCD. Whenever you have a fraction, you have to find the LCD. Let's go ahead and factor this if possible. So this will be x times 4, x divided by 4 times x minus 4. So factor if possible. Minus 5 over 1. There's an invisible 1 here. And then this is not possible to factor. So x minus 4, it's not possible. So the LCD is 4 times 1 times x minus 4. So in other words, it's 4x minus 4. Obviously, when you go 4 times 1, you just get 4. So, however, if this were a 3 or something, then it would be 4 times 3, which would be 12. We'll cross that bridge in another example. So in this example, this is your LCD. So you want to multiply all the numerators by 4 times x minus 4. All the numerators. Do not multiply the denominators. Only the top gets multiplied. And now you're going to simplify this as much as you possibly can. So you can cancel out the 4s here. You can cancel out the x minus 4s. Those are special factors of 1. Yeah, you don't really need to write 1. You just cross them out. It becomes 1. You don't get any canceling here. Nothing cancels here. Over here, you're going to get the x minus 4 is going to cancel. So now you have x minus 20. 5 times 4 is 20. X minus 4 equals 1 times 4. 1 times 4 is just 4. All right. And now this is the equation that you're actually going to solve. You're going to solve it just like a linear equation. The negative 20 is going to get distributed. Be careful with your signs. Okay. And now you've got x minus 20x. So that's going to be negative 19x. If it helps you to do the math, it's 1x, take away 20x's, which gives you negative 19x's. All right. I'm going to save this because we're going to have to check our answer in a minute. I don't want to erase this because I need to save it. So save that. All right, so now I'm going to continue working here. So I have negative 19x plus 80 equals 4. I'm going to subtract 80 from both sides. I'm going to get negative 19x equals negative 76. I'm going to divide both sides by negative 19. And I'm going to get x equals, what's that, 4? Yeah. 76 divided by 19 is 4, and it's a negative divided by a negative, so you get x equals 4. Now, this is not the solution. This is the candidate. That's what we call it before you actually check it. In order for this to actually be a solution, it has to satisfy the original equation. So do not type in x equals 4 right away. You might get it wrong, and then you're going to go, what did I do wrong? What did I do wrong? So you only have one candidate. We're going to check it and see if it actually satisfies the equation. So go ahead and plug in 4 all throughout this equation, everywhere you see an x. This is false. You cannot divide by 0. Division by 0 is undefined. Or you could just think of it as illegal. So this is false. 4 divided by 0 minus 5 is equal to 1 divided by 0. This is false. And so that means that this problem has no solution. And so we say the solution is DNE. DNE stands for does not exist. So the solution does not exist. It's undefined. Pretty easy to remember that. Look at in undefined, you have D, N, and E right there. I know they're out of order, but it's still DNE. See? DNE. Yeah. Some people say NDE. Not does exist. That sounds silly though, doesn't it? So we say does not exist. So we did all that for nothing. We only had one candidate. Our candidate was 4. And it did not satisfy the equation, so there is no solution. And unfortunately, you have to do that for every one of these problems because you never know. You never know whether or not your answer is going to be a valid solution or an invalid solution. Let's try another one. In general, I could just say solve. I don't have to say solve for x. 3 over x plus 1 minus 1/2 is equal to 6 over 3x plus 3. Okay, so the same idea. We want to find the LCD. Okay, so the LCD, we're going to factor this if possible. Whatever denominator looks factorable, that's the one you want to try to factor. Sometimes none of them are factorable. That might happen. That's why I always say if possible. For example, x plus 1, you can't factor x plus 1. 2, you can't really factor 2. I mean, other than the trivial factoring of 1 times 2, which really doesn't count. So we want to factor the denominator here. That's going to be 3 parentheses x plus 1. That's the factorization of 3x plus 3. So our LCD is going to be 2. We've got to use all the denominators. 3 and x plus 1. Now these are both copies of the same thing. So if they are the same, you only need one of them. It's the least common. All right. You probably can't see that. So that'll be 6x plus 1. Kind of got off the screen there a little bit right there. That's driving me nuts, so let's go ahead and do it like this. Is that better? There you go. So 2 times 3 becomes 6. I wouldn't bother with multiplying these together. It's better if you leave them separate. You'll see when we put it over here, it's better to leave it in this form. So you're going to multiply all your numerators by 6 parentheses x plus 1. and then cancel as much as you possibly can before you go to the next step. So in the first term, we can cancel x plus 1. In the second term, we can cancel a 2. 2 goes into 6 3 times. Canceling is also known as dividing. Yeah. So x plus 1 divided by x plus 1, those divide out, becomes 1. 6 divided by 2 divides out, becomes 3. Over here, you can cancel the x plus 1s, and you can cancel the 3. Just pick one of these 6s to cancel it with. Don't do both, just pick one of them. So I'm going to pick the first one. 3 goes into 6 2 times. So that 6 is now a 2. So now we have 3 times 6, which is 18, minus 1 times 3, that's 3, and then parentheses x plus 1. Over on this side, all the variables are gone. You just have 2 times 6, so that's 12. Remember what I called this thing in the front of a parenthesis? If you see an easy operation like 18 minus 3, that's called bait. Do not do 18 minus 3. The 18 goes after you've gotten rid of the parentheses. Then you can combine the 18. You have to use the distributive property before you do any adding or subtracting. All right. I can't tell you how many times I've seen people do everything right, and then they'll see something like that, and it'll end up screwing up the whole problem. So just be careful. Now you can combine the 18 and the 3. Yeah, over here. 18 and this 3 here combine to become 15. 18 positive and negative 3. And you can take it from here. These look like linear equations. They look pretty simple. Negative 15, negative 15. You're going to get negative 3x equals negative 3. I'm just bringing it up here so you can see it. Divide both sides by negative 3. And you get x equals 1. And again, you don't know if this is right. This is your candidate. You must check. All right. Now on the homework, you get a second chance. You could type it in, and if it says it's wrong, then you know that probably is not a good candidate. But on the test, you won't get a second chance. So you want to check ahead of time before you click submit, because once you click submit, it's too late. All right. Let's go back to the original problem here. Take your candidate and plug them in and see if it's true or false. If it's true, well, then that means the candidate is the solution. If it's false, then that means this was a false candidate, also known as an extraneous solution or extraneous root. So everywhere there's an x, I put a 1 because that's my candidate. Here and here. 3 halves minus 1 half equals 6 over 3 plus 3. 3 halves minus 1 half is 2 halves. 6 over 6. 1 is equal to 1. Yes, it's true. And so this is a valid solution. It's a coincidence that these are 1. All we really care about is whether it's true or not. All right? It's not always going to be 1. It just happened to be 1 this time. But what you really want to do is simplify both sides and then verify that they're not a false. It's not a false statement. A false statement would be like 5 over 0 equals 6 or something like that, Or 3 plus 2 equals 9, or I mean, some kind of false statement that just does not make any sense. All right, so this is a true solution. Good. So a solution is a candidate that is true. Yeah, that is a real solution. Okay, let's keep going. Example 3. Four over x minus 1/5 equals negative 5/2 plus 4 over 5x. I left out the instructions. All of these have the same instructions. Solve, check, simplify your answer. Try not to use a calculator. All right? If you get some calculators, just give you decimals that just don't really behave very well. Okay. We're only going to use calculators when we are specifically instructed to do so, okay, which is not very often. It's just there as an emergency scenario. Word problems, typically. All right, so LCD, we've got an X, we've got another X. Now you got to be careful. Sometimes people will multiply these two X's together. That would be too big. The key to an LCD is the word least. Yeah? Oh, you can't see that. You want to think least, not greatest, right? Least. So the least common factor of X and X is X, yeah? You also have a 5 and another 5, but again, the least is just 5. I like to put it in order. And then you have a 2. So your LCD is 10x. All right. You do not need to multiply 5 times 5 and get 25. That would be too big. That would not be the least. All right. So now we're going to go across the numerators and multiply them all by 10x. Make sure you do all the numerators. Here's a little trick that I use for negative fractions. I bring the negative up to the numerator. It's a lot safer to have it up there. I'm just rewriting it. So that's negative 50x over 2. See, I'm bringing the negative up into the numerator. And then now I'm going to simplify. If you want to start simplifying early, you can, but if you knock something off, if you cross something off prematurely, you're never going to be able to go back and recover. So it's better just to wait one step. I usually simplify in the second step. So cancel out your x's, cancel out the 5 and the 10 gives you 2. Cancel out the 2 and the 50 gives you 25. It's going to be a negative 25. Cancel out the 5 and the 40 gives you 8. 5 goes into 48 times. And just go ahead and cancel those x's there. So now you have 40 minus 2x equals negative 25x plus 8. I hope you're noticing something. All of these equations end up looking very simple by the time you actually start solving them. Right? If you're actually trying to solve the complicated problem, you're doing something wrong. I mean, this is math basics. You take a complicated problem, you follow a series of steps to make it a simple problem, and then you attack it once it's simplified. You never try to attack the complicated problem. I want to move all my x's onto one side. It really doesn't matter which side I go. If you don't care, you can just always move your x's to the left. I don't particularly care. the X could just as well be on the right side and it would still be a candidate. And now once I move my X to the left, now I'm going to move my constants over to the right. So I've got 23x equals negative 32. Divide both sides by 23. And I get negative 32 over 23 as my candidate. Negative 32 over 23. I don't really care where you put the negative sign. Sometimes you might put it out in front, but like I said earlier, I think it's safer just to have it up top. Now again, I don't know. This could be right. It could be not. It could be a DNE. I don't know. You never know until you check. There really is no way of predicting. Yeah, it's almost like every equation kind of looks the same, and you don't really have a method for predicting. With linear equations we do, and with quadratics we do, but with rationals, it's literally you never know what you're going to get. It's like that old saying. Now make sure you use the original problem to check. Don't use the simplified version of the problem. So this is your candidate. Plug it in everywhere you see an X. So you get 4 over negative 32 23rds minus 1/5 equals negative 5 halves plus 4 over 5 times negative 32 23rds. Okay. Now here's where, you know, 5th grade was the most important, or maybe 4th grade was the most important time of your life. Everything you ever needed to know about math, you learned it by the time you were 10 or maybe 12 years old. All right. In fact, most math problems are just unresolved childhood issues. Yeah. So you need to think back, you know, remember when you were 12 or 10 or whenever you learned how to do this, you take the denominator and you flip it and multiply. So you have 4 over 1, there's an invisible 1 there, times 23 over negative 32. And again, I don't really care where you put the negative. I'm going to use parentheses just to be safe. The negative could just as well be on top. I need the space right here, so I'm going to just put candidate up here. And then I can erase this. All right, so I got negative 5 over 2 plus 4 over... what is that? That's a negative 160 over 23. Yeah, this is a 5 over 1 I'm multiplying across. And again, I'm going to do the flip and multiply. Flip and multiply. So now I've got 4 goes into 32 8 times. So that'll be 23 over negative 8. And if you want, you can move the negative back up to the top if you like. I'm just going to leave it where it is for now. Let's go ahead and flip that, guys. So that's going to be 4 over 1 times, we're flipping this, 23 over negative 160. If I had a bigger whiteboard, I would just keep working down, but I'm all out of space. I got to run back up here to the top. So I've got 23 over negative 8 minus 1/5 is equal to negative 5/2 plus, now down here I can cancel, 4 goes into 160 40 times. So that's going to be 23 over negative 40. Not sure if you can see that. I did 4 goes into, let me do that one more time. 4 goes into 160 40 times. Yeah, 160 divided by 4 is 40. If you have to use a calculator, that's fine. Just realize what you're doing when you do that. Okay, now I'm going to do what I said you can do earlier. See how the negatives just look strange down in the bottom? You can, anytime you have a negative fraction, I don't care where you put the negative, but I think the safest place is up top. Okay. Here you have plus a negative. You can just say minus. Whenever you have plus and a minus, you can just make it a minus because you're adding them, yeah, or subtracting. It means the same thing. Okay. I hope the LCD here is clear. Yeah, the LCD is 40. Yeah. 8 goes into 40. 5 goes into 40. 2 goes into 40. And 40 goes into 40. So the LCD is 40. This little cloud here. Mental math. There's my LCD. Okay. So I'm going to multiply everybody by 40. If you're watching this video, you're probably going, wait a minute, you're spending more time checking than you did solving. That's exactly the point. This is the reason why I have not been checking in all the previous lectures. But in this lecture, there's no way around it. I have to check. It's the only way I'm going to know whether this candidate is correct. You can never trust the candidate. All right? They might tell the truth. They might not. You have to test them and see. All right, let's go ahead and finish this up. 8 goes into 45 times. Negative 23 times 5 is negative 115. 5 goes into 48 times. Negative 1 times 8 is negative 8. 2 goes into 40 20 times. Negative 5 times 20 is negative 100. 40 goes into 40 one time. Negative 23 times 1 is negative 23. The left-hand side says negative 123. The right-hand side is also negative 123. Check. This is true. And so this is no longer the candidate. This is a valid solution. Or you can just say the solution. So I did all of that work to verify that my candidate was in fact telling the truth. Yeah. It's really weird. Sometimes a really good candidate lies and is not the correct answer. Sometimes an awkward, strange-looking candidate that you're not quite sure about, it ends up being the right one. Right? So you never know. You have to check. That's the whole point of this lesson. Okay, moving right along. Moving right along. Got it? Valid solution? Good to go. If this was reducible, I probably would have reduced it a long time ago. I should have mentioned that, but it's not. That's why it sort of looks so awkward. Never use a calculator. If you put this into a calculator, it's going to fill up your whole screen, and you're going to go, oh my God, that doesn't make any sense, right? And it would make this process a heck of a lot worse. Calculators are only for worst case scenarios. All right, so example 4. Another rational equation. So a couple things I want to mention. We've been talking about this in the first three examples. You want to look at the denominators and see if there's any factorization that you can do to make your life a little easier. But notice that these are non-factorable. X plus 3, non-factorable. X plus 4, non-factorable. Now 6 is factorable. You can factor it as 2 times 3. However, since the other two denominators are non-factorable, factoring this denominator is really not going to help. So the term that we use for this is when all the denominators are relatively prime, means they have nothing in common, then that means the LCD is just all of them. I'm going to put them in this order. I'm going to put 6, and then x plus 4, and then x plus 3. Okay, so that's going to be my LCD. It's all of the denominators multiplied together. The order doesn't matter. I just chose this order mainly because I like to put the constant out in the front, and these two can be in any order that you like. All right. And then another comment that I want to make when this type of thing happens, I might have mentioned this in a previous example, is this negative sign here. That can be a little bit dangerous. So what I'm going to do is I'm going to rewrite it with the negative sign in the numerator. So this negative sign is going to go up into the numerator, and so it's going to look like a -1. All right, you'll see why that helps in a little bit. Now, technically, when you do that, there's an invisible plus sign right here because you're changing a subtraction into adding a negative. Now, this invisible plus sign is really just a technicality. It's not really going to matter all that much. So remember how we did this in the first three examples? You multiply all the numerators by the LCD. It's very important that you only do the numerators. All right? Some people learn this technique in other courses, and they get told to do the top and the bottom, and it causes all of these problems that I have to then undo in this class. All right, so let's go ahead and do that. It's going to be a little bit messy for a minute. 6x plus 4, x plus 3. And technically, that's multiplying. 6x plus 4, x plus 3. And then again over here, 6x plus 4, x plus 3. And just like in the other examples, most of these factors will cancel out. At least the denominators will. So you get x plus 3 cancels x plus 3. X plus 4 cancels x plus 4. And remember, this type of canceling is really division. So you're basically saying that these divide out and become 1. All right. And then 6 divided by 6 becomes 1. All right, now once you've done that, now you're going to multiply everything out. So 1 times 6 is 6, and then x plus 4. All right. Now technically this is plus, and then -1 times 6, which is -6 times x plus 3. Now again, you don't really have to write plus a negative. I'm just being extra careful that I don't lose that negative sign there. And then here you have a 1, and then x plus 4, x plus 3. All right. So here's a couple things you can omit. You can omit this plus sign, and you can omit this 1. They're not going to affect the result as long as you're careful with everything else. Okay? So now we're going to distribute 6 times x, 6 times 4. So that's going to be 6x plus 24. Now here's where I need to be really careful. This is a -6 and a -6 times 3. So that's -6x and -18. All right, and that's kind of where that invisible plus sign went. It's technically right here, yeah, plus -6. But now I've simplified that, so it's going to be gone. And then over here, you're going to distribute x times x is x squared. X times 3 is 3x, positive 3x. 4 times x is positive 4x. And 4 times 3 is 12. Positive 12. If you already well versed in all of this, you probably already combined those and you got x squared plus 7x plus 12. Oftentimes people can just read this, do it all in your mind, if you're good at this, and then jump right to here. I hope that you get that far if you're not already that far. Over here on the left-hand side, you're going to simplify. You got 6x and -6x. This is pretty common. It's not going to happen in every problem, but on several problems, you get those will cancel out. Be careful here. You got 24 and -18, so that's going to be positive 6. Yeah, 24 and -18. All right. Moving right along. Let's see. I'm going to have to erase some of this stuff. So I'm not sure if I've shown you this trick before, but oftentimes I like to rewrite the equation. So I like to write it x squared plus 7x plus 12 equals 6. I'm just reversing the left and the right, If the left side is equal to the right side, then you can switch it. Equality is, reversible. If A equals B, then B equals A. You can reverse the order. It just makes it look a little nicer when you're solving it. Move the 6 over to the left-hand side. Set it equal to 0. Yep, there we go. Make sure your signs are correct. Personally, I've screwed these up in the past just by not being careful with the pluses and the minuses. So just be really careful with that. And you want to try to factor this. In fact, there are other techniques that I showed you. Quadratic formula, factoring doesn't work, or completing the square or something like that. I always try factoring first. It's usually the easiest method. So two numbers that multiply to be 6. Let's try 1 times 6. Oh, and they add to be 7. And then make sure the signs are right. They're both plus. Okay. Remember the zero product property? You have two factors that equal 0. That means that each one is equal to 0, but there's no guarantee that they're both correct. So we use the word or. Maybe I mentioned this before. It's soup or salad. Possibly both. But the word or introduces the possibility that they might not both be correct. Okay, and so here are our candidates. We're going to move the 1 over by subtracting 1. We're going to get x equals -1 or x equals -6. These are our candidates. You should always check. You never know. They could both be right. All right. So go back here to the original equation and check our candidates. Let's try x equals -1. So we're going to plug it in right here. So you're going to get 1/2 minus 1/3 is equal to 1/6. That's actually true. Yeah. Check. 1/2 minus 1/3 is 1/6. If you want to see the math on this, it's a little bit of a step here. 1/2 is the same as 3/6. Hopefully you all remember your basic fractional arithmetic. 1/3 is the same as 2/6, and 3/6 minus 2/6 is 1/6. Check. It checks. All right, so that candidate is good. Let's check the other candidate, -6. Here, I'm just going to kind of fudge the numbers here a little bit. I'm going to replace that with a -6 and that with a -6. So that's going to be 1 over -3 minus 1 over -2. So that is, it's getting kind of messy here. That's -1/3. You've got 2 negatives here, which will turn to a positive. It's minus -1/2, which is +1/2. Well, that's the same thing. Yeah? -1/3 plus 1/2. It still checks out again. All right? And if you don't believe me, go ahead and do your mental check here to mentally check that. Or if you want, you could plug it into a calculator, or you could actually work the whole thing out. -1/3 is the same as -2/6. +1/2 is the same as 3/6. -2/6, that's this one, plus 3/6 is in fact still 1/6. So they both check. Okay. Read carefully. Some problems will just have you list in order. So you would just say x equals -6, -1. Right? And you can kind of tell by what the question is asking. You know, if it literally just says x equals and it gives you a box, just a single box, then you would list both of the numbers with a comma. All right, don't put any brackets or parentheses or braces around your answer. These are just two distinct values. Typically, we list them in order, -6 to -1. Other problems, and I want you to read each problem. I intentionally don't make them have all the same instructions because you just get too comfortable that way. Other problems say x1 less than or equal to x2, and you get 2 different answer boxes like this. All right. And so you got to put the -6 in this answer box and the -1 in the other answer box. Remember, with negative numbers, the number that appears larger, 6, looks bigger, it's actually smaller. Right? Think of it as money, right? You owe 6 versus owing 1. All right. Okay, so just be careful. Some problems have you put them in the same box. Other problems have you put them in separate boxes, and the most important thing, other than knowing how to solve an equation, is knowing how to answer it correctly. Okay, so we're moving on to example 5. All right. So, again, these problems all start with factoring if possible. If it's possible, factor it. Notice it just got really dark. That's that smoke that's up in the air, if you guys have been paying attention to the news. So if possible, or went in front of the sun, if possible, factor this, right? So x minus 1, no, can't factor it. X plus 3, no, can't factor it. X squared plus 2x minus 3, yeah, you can factor it. And I'll give you a hint, all right? And this is true for almost every one of these problems. If you have a trinomial or any type of, quadratic equation, you can always factor it in this section. Every single one of them are factorable. I didn't give you any trick questions that are not factorable. So we're going to factor this. I'm just going to put it right here. It'll be xx 3 and 1. 3 times 1 make 3. And look over here. It's a positive 3 and a negative 1. And that is not a coincidence. These problems are all cooked up in advance so that that's possible. All right. Turns out that if I don't cook these up ahead of time, they're basically all unsolvable problems. And I don't want to give you a whole homework assignment of unsolvable problems. So, I went back in my little math workshop and cooked up a bunch of problems that are all solvable. Okay? And so that's your LCD. Yeah. That's your LCD. See, you got x minus 1, x minus 1, x plus 3, x plus 3. So this is the least common. So you're going to multiply everybody on top by the LCD. Bring your own parentheses. I know it's a lot of writing. All right. So I multiplied all of the numerators by the LCD. And now I'm going to cancel. X minus 1, x minus 1. X plus 3, x plus 3. X minus 1, x minus 1. X plus 3, x plus 3. Now we've got x plus 1, x plus 3. Coming down. Equals, bring down that equal sign, don't lose it. What do we got? Negative 8, x plus 1, or sorry, x minus 1. Almost blew it again. Pluses and minuses, that's going to be your downfall if you make a mistake, including myself. All of these x's canceled, so you just have 8. It's funny, we all make the same mistakes. Basic math, intermediate math, advanced math, master's degree, PhD, doesn't matter. You're going to make a mistake, it's going to be a sign, a plus or a minus. Everybody makes the same types of mistakes. I'm no exception. X times x is x squared. Then we have x times 3, that's 3x. I don't know why I'm doing it this way, but whatever. 1 times x is 1x. And 1 times 3 is 3. We're almost done. Negative 8 times x, negative 8x. Negative 8 times negative 1 is positive 8. And then bring down the other positive 8. You can't see that, I'll slide it over, and there you go. Now you can see that. So now you have x squared plus 4x plus 3 equals negative 8x plus 16. Set this equal to 0 and factor it. So you're going to go plus 8x, minus 16, minus 16. The right-hand side equals 0. Now you've got x squared plus 12x minus 13 equals 0. This is what you're actually going to solve. Kind of running out of room here. So I've got x squared plus 12x minus 13. That's going to be x. Two numbers that multiply to be 13. How about 13 times 1? You don't really have many other choices. Notice I'm not going to make the same mistake as last time. I'm going to be very careful with my signs. I want them to add to be a positive 12. So that's a positive 13 and a negative 1. If you wait till the end to put the signs on, you'll you'll be less likely to make a sign mistake like I might have made in the last example. Although we fixed it, but barely. I mean, just caught it at the very end. All right, remember that these are equal to 0. So you're going to get negative 13. And then the other one is equal to 0. You're going to get positive 1. And again, you can't trust these. They could both be wrong. They could both be right, like last time. Or there could be just one of these that are right. All right? And you never know. You might have an intuition. Some people have that intuition. They can just kind of tell, a little tickle in the stomach, or some maybe, mystical, premonition that tells you one of them's right or not. But I recommend not using any mysticism and just use math, right? Just solve it and see what happens. Although if you do have that gift, there's nothing wrong with that. All right. Let's go ahead and check negative 13. So I got negative 13 plus 1, negative 13 minus 1, negative 13 plus 3. Oh, God, this is going to be a pain in the butt. Negative 13 squared plus 2 times negative 13 minus 3. So I got negative 12 over negative 14 equals negative 8 over negative 10 plus 8 over 169 minus 26 minus 3. Remember, all I care about is whether this is true or false. Okay. So negative 12 over negative 14 is positive 6 over 7. You can reduce that. Yeah, they're both negative, so they divide out, become positive, and 12 and 14 are both divisible by 2. Same thing here. They're both negative, and they're both divisible by 2, so that's going to be 4/5 when you reduce that. The denominator, 169 minus 26. You want to keep track of that? What's 169 minus 26? That would be 163 minus 20, which would be 143. And then minus 3 would be 140. Reduce that. Does 8 go into 140? I'm not sure. I know I said calculators are a last resort. Well, we're in that situation right now. I just want to check if 8 goes into 140. It's not one that I memorized when I was a little kid. No, it does not. But they are both divisible by 4. 140 divided by 4 is 35. So you can reduce 8 divided by 4 is 2, and 140 divided by 4 is 35. Can you tell whether this is true or not? Again, do you have a good intuition? Do you have a good instinct? Were you really, really, really good at fractions back in elementary school? I don't know. It is true, but it's hard to see, right? It's hard to see the truth all the time. So let's go ahead and just resolve it so we can clearly see that this is true. The LCD is 35. So just multiply everybody by 35. Yeah. 7 goes into 35 5 times. 5 times 6 is 30. 5 goes into 35 7 times. 7 times 4 is 28. 35 goes into 35 one time. 1 times 2 is 2. Can you tell that this is true now? Sure enough, 30 is equal to 28 plus 2. So check. Negative 13 is a valid candidate. It's a valid solution. Yeah. The last candidate to check is 1. I'm just going to go ahead and plug it in right here. Save us a little bit of time. Plug in a 1. Plug in a 1. Plug in a 1. 1. 1. Is that true or false? You can tell it's going to be false. Anytime you get 0 in the denominator, stop. There's no need to keep going. Not necessary to continue. All right. If you get 0 in the denominator, it's an automatic fail. It doesn't mean you fail. It means the candidate fails. Right? They are not telling you the truth, right? 2 divided by 0, that is a lie every single time. That's a false statement. So that's it. You're done. 1 is not a valid solution. Just throw it away. Pretend like it never happened. And only give me the valid solution. So the valid solution is x equals negative 13. Okay, I don't have time on this lecture video to do the radicals. So watch out for part 2. We will cover radicals next in part 2. So stay tuned for part 2. Until then, Dr. Jordan signing out. See you on the internet very soon.